It is 128 bits long address, right? Second, is first it is 128 bits long address. Second, like it is represented in hexadecimal, right? And there is no broadcast address, right? There is no broadcasting. In IPv6, there will be only two things, either unicasting or multicasting. And it has 8 blocks. I will not say 8 octets, I'll say 8 blocks, because it does not have octets. Because the meaning by octet is what? That you are having 8 bits, but it does not have 8 bits. It has 16 bits in each block, right? It has 16 bits in each block. Then I would say it has, or it can have 4 characters, right? That's fine. 16 bits is enough, right? Because you know very well that in hexadecimal each character will be represented by 4 bits. That's mandatory, right? That's a thumb rule for hexadecimal, right? That each character of hexadecimal number system will be represented by 4 bits. And you know very well that in hexadecimal we are having characters from 0 to 9, and of course A to F. Zero to 9 and A to F, right? So including all these characters, we have hexadecimal number system. So the lowest value is 0 and the highest value is what? F. And F is represented by 15 in decimals, and if you convert this 15 into binary, then it will become 111. That is the highest value, right? So they defined this rule, or they made this rule that okay, each character of hexadecimal will be represented by 4 bits into binary. So if there is 0 in hexadecimal, it will be 000, right? And if it is 1, then in binary it will be 0001. This is in hexadecimal, right? And of course, how will you come to know that whether, let's say that I have written this 119, then how will you come to know that okay, whether it is in decimals or in hexadecimals, right? So there would be a base. If it is 10, which means that it is in decimals, right? If it is 16, which means that it is in hexadecimals, right? Fine. And after it, you are still remember that in IPv4 we were having mainly 3 types of addresses. That was it was unicast, and then it was broadcast, and then it was multicast, right? Then under unicast we were having public private, if you are remembered, right? Similarly in IPv6, if you talk about IPv6, in IPv6 we are having the 2 main categories. One is unicast and another one is what? Multicast. You understand? And under unicast again we are having several categories, like we are having the global unicast address, that is kind of public address, right? Global unicast address. And you can also call them aggregatable address or aggregatable address. Then you are having unique local address, that is same as private address, right? Finally you have link local address. right? So you are having global unicast address, aggregatable address, unique local address. I mean, you can call, I mean, both are same. Either you can call them global unicast address or aggregatable address. Unique local address are same as like private address, right? Link local address is, I mean, here in IPv6, this is really interesting, this link local address, and I'll let you know that what is the uses of this, right? But remember that for actual data you will not be using this link local address for actual data, especially in that case when you are transferring when you are transmitting your data out from your own subnet. Then you will never ever use this link local address, as per its name, link local address, which means that if you want to send your traffic on local link, which means within the same VLAN, within the same broadcast domain, then only you can use link local addresses. Otherwise you will never be able to use link local address. And one more thing that you have to remember, link local addresses will never be routable. In routing table they will never get installed. Routers cannot exchange their link local addresses, right? Link local addresses will never get installed in their routing table. Routers can install only either global unicast address or unique local address, which means private addresses or public addresses in their routing table. Fine. And then again you are having multicast addresses. This is to perform multicasting. Like over there in IPv4, if you remember, class D was reserved for multicasting. Class D, right? From 224 to 2239, if you remember, right? So similarly here in IPv6, again we are having a reserved range for multicasting itself, right? So that's the thing. Fine. Then after it, let's talk about that how can we represent this IPv6 address, right? So as you know that we can use any character from 0 to F, right? So let's say that your IPv6 address will be represented in this manner: D001 colon. It will be separated by colon. I mean, each block will be separated by colon. In IPv4 you were separating your octets by dot, by specifying dot, right? So this is D001 colon, and then you can use here 100A colon B00D again, and let's say 2105 colon 500A colon C2001 colon A003, right? And like C21A. That's it. So you are having eight blocks, right? So that will be your IPv6 address, right? So here you can see that in each block we are having 4 characters. However, it is not mandatory. It is not always mandatory to have 4 characters in a single block, right? Because if like for an example, if you are having only here you specified only C, right? Here you specified only C, and in that case it will be understood that before C all remaining 3 digits will be 0, right? All 3 digits will be 0 before C, right? So it will be understood now 000. It will be understood, right? So it is not mandatory to specify that, right? C001 once again. So now you must remember that in IPv6 first first 3 blocks are used to represent your global prefix. I mean your prefix globally, right? So it is used to represent your global prefix, or you can say we uses them to represent prefixes globally, right? And then this 4th block will be used for it will be your subnet ID, right? It will be used to define your subnet ID, and then last 4 blocks will be used to define your interface ID. The only thing that you are required to know about it is interface ID, right? I mean, you are not required to learn about the first 4 blocks actually in IPv6. You just need to remember that okay, first 3 are used for global prefix, and next 4th block will be used for subnet ID. Apart from that, you are not required to remember anything, right? But you have to remember last 4 blocks interface ID, because it will play a crucial role in IPv6, because without having an interface ID it is not possible for IPv6 to do work, right? And I'll let you know that how does it how do we allocate this interface ID, or in case if we are not allocating interface ID, then of course your device will be generating this interface ID by itself, right? So how will it be generating this interface ID automatically? So we will learn each and everything about it, right? But this is really important to learn for IPv6, this interface ID especially, right? So this is all about interface ID. So here in interface ID, we have came to know now that last 4 blocks will be used to represent interface ID, which means 64 bits, right? Because each block is containing 16 bits, right? So remember that 64 bits will be used to represent your interface ID. Fine. Then after, you know very well that it is not really easy to memorize that much long IPv6 address, right? So even you can have this IPv6 address in this manner as well, like F200:000:000:000:000:000. See, 0 is also part of is also part of IPv6, is also part of hexadecimal number system, right? So you can have that this type of IPv6 address, and then again 000, and then again 000, and then again you can have here 0001. You understand? So this is the thing actually. And then after, you see that we can represent it in this manner now, F200:dual colon actually and 1 directly, right? So you can short your IPv6 address if your IPv6 address is containing zeros, right? But remember, you can short your IPv6 address in that condition only where you are having only zeros in your IPv6 address, right? Because this dual colon represents, I mean, the meaning of this dual colon is that all remaining blocks are containing zeros, right? All remaining blocks are having zeros. That's the meaning of this dual colon over here, right? So you were already having, I mean, in this IP you are already having first block, last block, and then in between them you are having dual colon, which means all remaining. And how many remaining blocks are there? 6, which means all remaining 6 blocks are containing zeros, right? But the point is, like, if I modify it now, like for an example, in place of this 0, now I mentioned now 1, right? So it's not like that you will type it now like this, FT00 and dual colon 1 and then dual colon 1. That will be wrong, right? You cannot type it in this way, right? Because you cannot remember that in a single IPv6 address you cannot specify your dual colon multiple times. You cannot. You know why? Because at that moment you will not be able to know that which dual colon is having how many blocks. Might be it is having 2 blocks, it is having 3 blocks, or 4 blocks, right? Or whatever it is, right? So it will be depending. So that is why it is not possible to have double dual colon in a single IPv6 address. You can have maximum 1 dual colon in a single IPv6 address, right? So you can type it either, and even in place of this, I'll make it 0 once again, and here I'll make it 1 actually. This is right, and this is, let's say, 1. So now you can type it in this way, F200 dual colon 1 colon 0, because all of them are 0. So if you specify only 0, it will work fine, right? Then colon 0, then colon 0, and then colon 1. That is fine. That's correct, right? Or you can type it in this manner, F200 colon 0 colon 0 colon 1 and dual colon 1. That is also correct, right? So you can represent your IPv6 address, I mean this type of IPv6 address, in both manners, either this or this. Both of them are correct statement. So in this way you can shorten your IPv6 address if it is containing zeros in that. If it does not have zeros over there, then of course you cannot make it. You cannot short it. You cannot shorten it out, right? And if you do not short your IPv6 address, then of course it will be really difficult to memorize that, right? So that's the reason that we have all these things, all these shortcuts in IPv6, right? Fine. Then after, you must know that if you talk about global prefix, right? Global prefix, or aggregatable address. So they will always start from this, like in IPv4 we were having classes, class A, class B, class C, like class A will start from here to here, class B will start from here to here, class C will start from here to here, right? So in similar fashion we are also having those things in IPv6 addressing as well. And here global prefixes will always start from 2000 12:/3. This is the this prefix is specified for global prefixes only, right? You can say global unicast address. These are global unicast addresses, or you can also call them aggregatable address, right? And if you talk about unique local addresses, unique local address. So if you talk about unique local address, they will always start from FC00:/ I think that is 7. What happened? So this time you can see that it will be starting from FC00:7, and if you look at the link local addresses, and they will start from FE80:10, right? And if you talk about the multicast addresses, for multicasting we are having FF00:8, FF00:8. Now the big question is that what is the meaning by 2000 2000:3? We have to know about its meaning, right? So let's start it now. So actually the meaning by 2000 and :3 means, if you convert it into the binary now, right? So 2, which means 0010. What is the meaning by 0? 000. What is the meaning by again 000, right? Again, what is 000? Colon 000:00, because what's the meaning by dual colon? That all remaining blocks are having zeros. Now /3, which means first 3 bits are reserved. These 3 bits are, you cannot modify them. Apart from them, you can modify. You are free to use all other bits, but you cannot use first 3 bits. First 3 bits are reserved. Now if you convert this 4th bit, in place of 0, if you make it 1, then you will see that it will become 3. That is why, remember that your global unicast addresses, or you can say aggregatable addresses, will start either from 2 or 3. If your IPv6 address is starting either from 2 or 3, that means that it is a global unicast address. And then after, you can have anything, because you are free to use all other bits, right? Only first 3 bits were reserved. It is same as like for class A/8, something like that, right? Not /8 actually. I think some bits were reserved over there, right? Like for class A, first bit was reserved. For class B, first 2 bits were reserved. For class C, first 3 bits were reserved, right? In similar manner, here in IPv6, again we are having all those things. Like here there is no class, right? There is no class A, class B, class C, but yeah, there is something like that, okay, this number of bits will be reserved and you cannot modify them, something like that. So this is for global unicast prefixes. Then if you are having unique local addresses, which means that they will start from FC00:7. If you convert now it into the binary, F, which means 111, C, which means 12, 1100, right? 0, which means 000:00000, fine, colon, dual colon, which means all others are having zeros only, so they will be having only zeros, right? /7, which means first 7 bits are again reserved. You see that first 7 bits are reserved. You can modify them, but you can modify this 8th bit, right? This one, in place of 0 you can make it 1, and if you make it 1, it will become D. will become D, because it will become 13 in that case, right? So remember that your unique local addresses will start either from FC or FD. That's mandatory. First two characters will be either, first will always remain F, second character will be either C or D, and then after you can have any character. That's the meaning of this, right? Then after it, you are having link local addresses, right? Which means FE80 dual colon /10. If you convert it into the binary, which means 111, E, which means 1110, 8, which means 10, and 0 colon zeros, right? Because dual colon is there. 10 is what? That up to here all bits are reserved, but these bits are not reserved, right? These all bits are, you are free to use them, right? So now the point is, you can, now this is 00, it can be 01, it can be 10, it can be 11. You understand? That is why your link local address can be FE8, FE9, FEA, or FEB. That's it. That's it. Understood? Right? And then after you can have any character, then colon, any character, colon, any character, colon. Fine. For multicast, FF00 dual colon /8. I hope that you have understood it now automatically. First two characters are going to be reserved. Then after you can have anything. Is not it? It will start from FF only. So if anything is starting from FF, which means that it is a multicast IPv6 address, right? Now remember that in IPv6 there is no ARP. But they have not modified OSI model. Still, they have to perform layer 2 encapsulation, which means that in case if you are using Ethernet connections, then again you will require to get to know about the next hop MAC address, gateway's MAC address. How will it be possible to get the gateway's MAC address if you are not having ARP protocol over there? Remember that in IPv6 we do not have this ARP protocol, right? So for that purpose we are having here NDP, that is called Neighbor Discovery Protocol. In IPv6 we are having NDP, Neighbor Discovery Protocol, and this NDP will be using further ICMP v6, and ICMP v6 is an upgraded version of ICMP v4, right? And ICMP v6 will use further some messages, like there are some messages which will be used by ICMP v6 to process all this stuff, right? Like how will it discover its neighbors, how will it get the MAC address of neighbors, how will it get the MAC address of gateways, everything, right? So for that purpose ICMP v6 will be using some types of messages over there, and those messages are known as like router advertisement, router solicitation, neighbor solicitation. These messages will be used by ND, or you can say IPv6, to perform tasks. You know, implementing routing protocols or MPLS for IPv6 is quite easy. But the main concept is to understand, I mean, the main you can say, the most important thing about IPv6 is to understand its background process, that how does it really work. Like we learned about IPv4, right? Like it stands, ARP contains all this stuff, this kind of, I mean, all these components. This is the uses of this component, this is the uses of this component. In similar manner, we have to learn this IPv6. And then after, it will be quite easy, like, you know, it will be very easy to configure routing protocols for IPv6, like API, CRP. We don't have anything to configure over there, right? Like there is nothing new as compared to IPv4. Everything will remain same as IPv4. Even commands will also, I mean, most of the commands will remain same. In place of IPv4, you just need to mention IPv6, and the most of the commands will remain same. So, you know, here we are not to learn that how to implement routing protocols over IPv6, because that is quite easy and we can cover, you know, like multiple protocols in a same class, in a single class. Today I will try to make you understand that, okay, how does it really work. Like, for an example, if I allocate an IPv6 address, what does it perform first? If I need to reach gateway, what will it perform then? How will it get the MAC address of gateway, right? So over there we were having ARP cache, so here which kind of cache it will build and everything. So IPv6 header is a 40 bytes long header, remember, right? 40 bytes long header. Like if you talk about IPv4, it was 22 60 bytes long header, right? But in most of the cases it was either 20 or 24, right? But in case of IPv6 header, it is 40 bytes long header, right? And I told you this dual colon one is kind of loop back address. Over there, loop back address is in IPv4 what is starting from 127, right? But here in IPv6 it will be dual colon 1. That's very simple, right? Then aggregatable address will start either from 2 or 3, I told you, right? And then link local address will start from FE8, but you can also go for FE9, FE8, FEB, right? Maximum FEB. Then site local, FEC, nowadays we call this site local as a unique local addresses. Nowadays we are not using this keyword site local, right? And for that we are having like FE, not FE, I think that was FC00, right? Multicast will start from FF, so that's fine. Solicited node is, I mean, for that we are having this address, right? FF02, which is a multicast address, fine. I'll let you know that what is the meaning by solicited, and this is IPv6 header, and it is 40 bytes long header actually. Even you can look at there, like version, traffic class. Version is same as like over there we were having version field in IPv4, right? Traffic class is kind of TOS that we were having in IPv4, right? TOS type of service, right? So here we are having traffic class, flow label, and payload length is kind of packet length. Next header is to whom, I mean, it's kind of protocol field, right? It's kind of protocol field. and hop limit is same as TTL value, and then source address and then destination address. Here IPv6 address is a 128 bits long address, which means like we are having how many bytes we are having over here? I think 16, right? So 16 plus 16, 32 bytes are for addresses only, right? And remaining in remaining 8 bytes we are having all other things, right? 4 bytes and 4 bytes. This is for 4 byte and this is again for 4 byte. I would suggest you to go for it right first now, like here in IPv6. However, I will try my best to make you understand, but still you have to do self-study for it. You have to read this book. I mean, might be that you are already having IPv6 in your book, right? So you can go through your own book as well. Even you can also collect this book from me. This is I think this is Jeff Doyle book, right? This is Jeff Doyle's book, and you can also go through this book as well. So this is, you see, IPv6 functionality. If we say that okay, this device supports IPv6, which means that it has to support now all these functionalities. If any one of them is not supported by your device, which means we can't say that this device supports IPv6. So IPv6 must be supported. ND, stateless auto configuration, anycast, multicast, and MTU path discovery, right? So all these things must be supported by your device, so that we can say that okay, this device supports IPv6. You can see that this command is just used to enable routing onto Cisco devices like IPv6 unicast routing, right? Then after you are having here ICMPv6 in IPv6, right? And ICMPv6 can give you this type of error messages like destination unreachable, packet is too big, time exceeded, parameter problems, right? All these things. No route for the destination, access is administratively prohibited, like you have configured an ACL, right? With the help of ACL you are dropping your data, address unreachable, port unreachable, something like that. Then you are having a neighbor discovery, right? As I told you, the neighbor discovery protocol addresses many problems related to node on a single link. It provides the functionality for serverless automatic configuration, like if you do not have a DHCP server in your network, but still you want to allocate an IPv6 address to your devices automatically, then you can use, you can allocate them with the help of ND, neighbor discovery. Router discovery, you can discover a router, like your host can come to know that how many routers are available in my network, right? With the help of neighbor discovery. Prefix discovery, of course you can also perform prefix discovery for prefixes with the help of ND. Address resolution would be performed by ND itself, right? And neighbor unreachable detection will be performed by ND itself. Link MTU discovery will be performed by ND neighbor discovery. Next hop determination will be performed by ND. Duplicate address detection will also performed by ND. So you see that how many tasks are performed by a single protocol, ND. Previously, to perform all these tasks, we were having DHCP, we were having ARP, proxy ARP, you understand? Proxy ARP in something like that, right? And DHCP, and so many things were there to perform all these things, right? But here in IPv6 we are using a single protocol, that is ND, and with the help of this ND we are performing all these all these functions. That's the advantage of.
Is this a standard or Cisco corporate?
It's a standard, yeah. Right? So when a node is initialized, it must know a few things before it begins communicating. Like if someone asks you that okay, let's say that we are going to allocate an IPv6 address on this host, so before communicating, how many things that it should know about, right? So it must know about its own address, it must know its own prefix information, so that it can figure out how to send packets to nodes located in other prefixes. It must know about any router on the link, so that it can find it can have gateway. It needs to know how to determine the next hop in the path to a destination, right? So that is the thing.
So what's the having address in your website?
What?
Address resolution.
Yes, it will perform address resolution as well.
What is the meaning of address resolution? Address resolution means
From IP to MAC. It needs to know that how to obtain the link level address, you see, associated with the non-network layer address like IPv6 to. It needs to know how large of a packet it can send, like it has to perform path MTU discovery, right? Path MTU discovery. To make communication run a lot smoother, a node should know some other things as well. It should be able to detect when a neighbor is no longer reachable so that it does not send packet to that neighbor. It should know about neighbors on its link. It should know whether the address it is trying to use is in use already by another node on the link or not, right? It needs to know that what other prefix are assigned to node on the same link, right? Because you can use now multiple prefixes on a same link. In IPv6 that is also possible to use multiple prefixes on a same link. It should be able to redirect traffic to the better next hop node if one exists for any destination. So it can also perform that. That is why it is also having redirect message, right? This ND. So that is why here you see that it will perform all these tasks with the help of these messages. What I told you: router solicitation, router advertisement, neighbor solicitation, neighbor advertisement, and finally redirect message. So these messages will be used by ND, and it defines 5 ICMP packets to provide IPv6 nodes with the information they must and should know before communicating. So it will be using these 5 types of messages: first RS, RA, NS, NA, and redirect. Now you should know that what are the uses of router solicitation and who can generate this router solicitation message, right? So remember, multicasted by a node when it wants router to send a router advertisement immediately instead of waiting for the next scheduled advertisement. First thing that you must remember, router advertisement can be generated by a router only, and router would be generating router advertisement periodically, right? Fine. Now a host came up, right? And that host wants to know about the routers, right? Now it has to wait for next scheduled router advertisement, right? So it will slow down the performance of the network, right? To solve that, there is a concept that whenever a node will come up, it will generate router solicitation immediately. And now if a router receives a router solicitation, it has to generate router advertisement immediately. If a router receives any router solicitation message, then router has to generate router advertisement immediately. Neighbor solicitation, I mean, like, I hope that you people have understood now router solicitation, right? It is just used by nodes to force router to generate router advertisement immediately without doing wait, right? Any initializing node may send the router solicitation so it can immediately learn about configuration parameters and about the existence of routers on the link immediately, right? Second, router advertisement sent periodically or in response to a solicitation. Understood? Routers advertise their presence as well as provide information necessary for a node to configure itself. Of course, in router advertisement, router will provide its own information like prefix information so that node can obtain an IPv6 address automatically, right? And along with that MTU information, you understand? Its own MAC address, you understand? So that node will come to know gateway's MAC address as well. So all this information would be given by a router in router advertisement, right? And remember, router advertisement can be generated by routers only, not by the end hosts. Neighbor solicitation is kind of ARP request. It is kind of ARP request. Enables a node to determine the link layer address of a neighbor, or to determine whether the neighbor is still reachable via a cached link layer address. Like, of course, like in ARP table, we were having ARP entries, right? And that was called ARP cache. So here, because we do not have ARP protocol, but still there must be some cache, right? So that it will keep learned MAC addresses, right? So to keep learned MAC addresses, it will be having neighbor cache. Here we will call that neighbor cache. So if you are having neighbor's MAC address in your cache already, then how will it be possible to know that, okay, whether this neighbor is still reachable with using this MAC address or not? So for that, again, it will be using neighbor solicitation. So it will be used, or you can say that IPv6 will be using neighbor solicitation to perform two different tasks. First, to get the MAC address, and second, to verify neighbor's MAC address. Second, neighbor advertisement. Neighbor advertisement will always be generated by nodes or routers in the response of neighbor solicitation. Or in case if its own MAC address has got changed, then it has to inform to others, right, that okay, my MAC address has got changed. Then also it will be generating neighbor advertisement. Understood? In more details, yes, this is, see, router solicitation. Read it. You have so many things.
Router solicitation is kind of ARP request.
No, it's neighbor solicitation.
It's neighbor solicitation.
Yeah. Router solicitation is a message which will be generated by a host whenever it will come up to force a router to generate router advertisement immediately.
And
Without doing
advertisement, we have a MAC address of the router.
of MAC address of the router, MTU size of the router, prefix information of the router, all this kind of information.
It's like a DSC.
Yeah, you can say DSCP packet. But in DSCP packet, you do not contain MTU size, you do not contain its MAC address, right? But here in router solicitation, router advertisement, you will be having all that kind of information. So I hope that you people have understood it now, right? So just go through it, right, once, and you know, redirection. Redirection is kind of, for an example, if you are having multiple gateways, right? I mean, a host generated traffic towards the gateway, right? And that gateway came to know that, okay, no, I'm not the best path for you, right? So it can redirect the traffic, right? It can tell back to the sender that, okay, I'm not the best path for you. Do one thing, send this traffic towards that gateway. That is the nearest to you.
That happens in XSRP.
Yeah. And some other things are also there. Like here, what can you do? What I know about it is something like this. This is router 1, right? And there is a switch. And you know, there is a host, Now they're in same VLAN, they're on same link, right? And they are using an IPv6 address from different prefixes. And even if you allocate two IP addresses on this, because in IPv6 it is possible to allocate an IPv6 address on a single interface from two different prefixes, from two different networks, right? Now, the point is, whenever you will try to ping from here to there, right? Because it will think that, okay, this destination is on different subnet, right? So it will send this traffic towards gateway, and gateway will receive it and will come to know that, okay, I have to send this traffic back to this, right? So now it will come to know that, okay, I'm not the best path for this traffic, right? So it will generate redirect message back to the sender that, okay, no, do not send this traffic towards me. Do one thing, send this traffic directly to this host. So for that purpose, here we are having this redirect message in IPv6. In IPv6, it is possible to allocate an IPv6 address on a single interface from two different networks. You can allocate multiple IPv6 addresses on a single interface.
Two different global address.
Yes, you can. So this is the.
Is there a limit how many addresses?
I don't know. See, I'm also not 100%, in IPv6.
So we can also count the IPv4 address, right?
What?
We can also count the IPv4 address, the same interface, right?
Yes, of course. That's called dual stacking, right? Just give me 1 second, please. Hello. Yes. Good morning, Santosh.